Hello and welcome to this session. My name is Dr. Neil Soggie for Educational Psychology, and within this module, Module 6, we will be focusing upon memory. Now, we've already talked about the different sorts of memories. Sensory memory, which is the sort of fraction of a second sensory residue of what you're hearing and what you're seeing, and then working memory, short-term memory, and then long-term memory. So I want to spend a little bit of time moving to the distinction between working memory, short-term memory, and long-term memory. Now, the obvious distinction is actually just, in fact, in storage difference. So long-term memory, sometimes just referred to as LTM, has a huge storage capacity. This is your memory like the hard drive of your computer. This is the memory you walk around with. It includes all the words in English. Just for example, we're talking 60 to 80,000 words. It includes everybody you've ever met, languages, faces, stories, locations, nursery rhymes, songs, TV programs, movies. Nobody knows the limit of the storage within your long-term memory. And it's not true that you remember everything that has ever happened to you. There's no reason to believe that this is true. But at the same time, though, you do have a huge amount stored in your brain in long-term storage. And nobody's actually sure what the limit is. It's finite, it's limited because your brain is limited, but nobody knows how big that information is. Nobody knows just how many terabytes you carry around in your brain. But we know it's a lot. Now, compare this to working memory, the short-term memory, which is actually very limited. Your memory of what you could store on or in, were you to hold in consciousness right now, is quite limited. Let's do a little exercise. Now, don't write these things down. I want you to just remember them as you sit here. I'm going to give you just a few numbers, okay? So you're paying attention now. Here's the numbers I want you to hold in your mind. 14, 59, 11, 109, 43, 58, 98, 487, 25, 389, and 54. Okay. Now that you have all of those numbers in your brain, now go find a pencil or a pen and write them down. Just think of this as an IQ test as you kind of engage in this process. Now, whether you decided to participate in this little experiment with me or not, just wants you to think about this. How many pieces of information do you think you held within your memory? See, the numbers are meaningless. And now, under normal circumstances, a cognitive psychologist once said that suggested that the standard memory storage of short-term memory is 7 plus or minus 2. And what that means is anywhere from 5 to 9, roughly, is the bits of information that you store in your mind. Now, some of you, I'm sure, can beat that. Some of you are not so good today. Now, 7 plus or minus 2 is what you can hold in your consciousness. Now I can tell you 14, 21, and you'll walk around, oh yeah, okay, 14, 21, and you hold those in your consciousness, no problem. But then I throw in 11 other numbers at you, and all of a sudden you can't hold them all. Some are going to simply fall out because you can only hold 7 plus or minus 2 in your conscious short-term memory. Now, this raises the question, 7 plus or minus 2 what? And the answer seems to be what psychologists call chunks. A chunk is a basic memory unit. It's something that you can think of as a single individual entity. Now, suppose I give you a string of letters like L, A, M, A, I, S, O, N. And if you don't know, if you can't form these into a word, and you have to remember them, these are 8 chunks. You have to just pick them up separately. On the other hand, if you break them up into 4 words, then you have just 4 chunks to handle. Now, if you know French and you break those letters up into 2 words in French, la maison, the house, it could be just 1 or 2 chunks. Now, how much you know depends and affects how much you memorize and how much you could store in memory, because it affects what counts as a basic unit of memory. And there's all sorts of examples about this. If I tell you 1101100101110, those of you who don't know binary numbers might have been able to remember 1100 or whatever I said. But those of you who are computer scientists or mathematicians, for whatever reason you know binary numbers, could convert that into a single binary number. And so for you, it's only 1 bit of information. And so it's a lot easier. Now, suppose you see a chessboard and the chess board is set up and you don't know how to play chess. It is murderously hard to remember that. Now, they've done experiments. They've taken people in the lab that don't know how to play chess and they've set up a chessboard and they say, okay, look at this for 5 minutes. Then they take it away. And then they set it up again. And it is murderously hard. There's a horsey thing on the side there that just seems to go there, or that pointy thing seems to go over there. And it becomes extremely hard to set up. Now, similarly, football coaches have been tested on their memories of football diagrams. And they seem to have a photographic memory of football diagrams because it corresponds to things that make sense for them. Architects could have a photographic memory, a perfect memory for floor plans because it makes sense to them. They understand it. And so the way you store things in memory, and this is a theme you're going to return to when you get to long-term memory, depends in a large extent how you understand it. And this shows up in expertise effects. Now, this is what happens so far in short-term memory, how much you hold in there. The question is, how do you get it into long-term memory? So you have long-term memory, your major storage system. How does information get from your consciousness to long-term storage? Well, there's one way in which sort of works, sometimes, but not very well. And it's called maintenance rehearsal. Suppose I said you have to remember this number, this string of numbers. And if you remember it in 20 minutes, you will get $10,000. And the string is my phone number when I was a kid. So let's say the area code is 607-854-2273. Now, if you tell that to a 4-year-old, well, the 4-year-old will say, I'll remember it. And then you ask them, what did I just say? Well, I don't know. If you tell it in because you know something, if a lot depends on it, you would know to do something to help remember it. The importance of the thing that you have to remember plays a huge role in the amount of attention that you are going to give to it. And this plays a huge part in how well you encode it, how important it is to hold in your conscious awareness, in your working memory, and keeping it there long enough that it will begin to transition to the long-term memory. Now, to get things into long-term memory, rehearsal is usually not enough. You usually need to do other things. Typically, you need a structure and organization. And one way to demonstrate this is in the classic depth of processing experiment, which nicely illustrates the fact that the more you structure something, the deeper you think about it, the better it gets entrenched in the long-term memory. So, in this study, what they did was they asked people, they told people that there's going to be words flashed on the screen, and all of the subjects saw the same strings of words. There were 48 words. They were not told to memorize the words. 1/3 of the subjects was told, look, some of these words are going to come out in capital letters. Some of them not capital letters. Press a button for capital letters, not capitals. Sure. The other group was told, some of these words will rhyme with train. Others won't. Press a button if it rhymes with train. And the third group was told, does it fit into the sentence? And the sentence is, the girl placed the blank on the table. Press a button if it does. And then they were asked as a surprise, what words did you see? And the findings looked like this. When they were asked to focus on just what the word looked like, memory was very poor. The sound, the memory was better. The meaning, the memory was even better. So if you want to remember something, the best way to remember it is to give it meaning, to give it sense. And this is illustrated through a very ancient technique, which is that the way to remember things that are otherwise arbitrary is to give them some organization through memory tricks, through vivid imagery, or songs, or poetry. And there's a lot of examples of this. Now, within your brain, there's a little horseshoe-shaped thing in the middle of your brain called the hippocampus. There's a part, and within your hippocampus, a large part of it involves spatial memory. It involves finding your way around in things. So think to yourself, the way that I find my way around school or around my house is with my hippocampus. And you think, well, that's stupid. But the thing is, you never forget when something gets put properly into your hippocampus spatial memory. You retain that information. And memory books on how to remember people's names usually try to exploit this type of thing. And so when you use things like poetry or dramatic images, all of those things work very well for helping you to remember things. So the memory books always or typically involve somebody like you meet somebody with very spiky hair and they say, "My name is Mr. Fish." And then you remember, you think of of a big fish impaled on their hair, for example. That gives you dramatic images that encode themselves deeply within your hippocampus, and that indicates that to your brain that needs to be encoded through your hippocampus into various parts of your brain, and in so doing, you are able to encode the information in a way that really helps to transform it into long-term working memory. Now, truth be told, dirty poems work even better. Obscene imagery often can come to mind, and that works actually quite well for encoding things into your long-term memory. Now, how to get information into your memory. That's how you do it. Okay? Complex imagery, using spatial, connect the things with spaces, and use poetry and rhymes and complex imagery, and all of those things will help to consolidate that information into your long-term memory. Then so that's how you get things into your long-term memory. Now, how do you get the information out? So it's exam time, and you got the stuff presumably in your head. You've been exposed to the information, but the question is, and assuming that you have encoded this information into your long-term memory and you haven't let it fall out, then how do you find it? How do you get this information out? You have to retrieve it. How do you figure it out? You need to have retrieval cues. Retrieval cues are just things that have been associated with what you have been trying to remember. And if you have to remember to, say, for example, replace windows, when you walk into the living room and you see that the window is cracked, that's a reminder that you need to replace the window. And if you had a lunch date and you forgot about it, and when you see the person that you were supposed to have that lunch date with, you go, oh yeah, I was supposed to have lunch with you yesterday. Oh, I feel so bad about that. Those are retrieval cues. Retrieval cues bring things back. But it's a little bit more complicated than that. There's a more general relationship between encoding and retrieval called the compatibility principle. And what this means is you're much better to remember something in the context in which you learned it. And this is also known as context-dependent memory and state-dependent memory. It's illustrated by one of the strangest experiments in the history of psychology, where they had people on a boat and then they had them scuba dive underwater. And they taught them things either on the boat or underwater with things that they held up. And then they tested them later. And it turns out that you'll remember it better if you're tested on it in the context in which you learned it. And it might be because then the retrieval cues help bring it back. But it's more general than that. If you have to remember something you learned in this class, for example, you will do better if you try to think about the place that you were when you learned it. And you will do better in your exam if you take it in the place where you learned it. That helps to bring back the cues. And it's not just the environment. People who learn things when they're stoned, for example, remember them better. Keeping stoned at a sort of low level doesn't disrupt your mental activities a whole lot. Now, you remember them better when they're sort of stoned than if they're non-stoned and completely sober. Similarly, if you study while you drink, then you should probably have a little drink before your exam. It's kind of like, don't change the context that you emotionally associate with processing this information. It's kind of like what happens in Vegas stays in Vegas sort of result. And similarly, this applies to moods. When you learn something when depressed, you have a slightly better recovery of it when you're in the same mood of depression than you would later if you were feeling good and elated. So emotional connections play a part in this. Part of what recovery of memory is getting back your original context in which you learned it. Elaborative rehearsal and retrieval involves the connection between different things. Elaborative rehearsal is that the more you think about something, the easier it is to remember. If you have to think about it, if you have to remember something, try to connect it to as many things as possible. Think of an image, make a joke about it. Imagine how you could explain it to somebody else. Imagine what the world would be like if it wasn't so. And the idea is that this sort of thinking about it makes connections in your memory so that you will learn it deeper and you will connect it to more memories, and that makes it easier to recover it later. Elaborative retrieval refers to a finding that when you want to get something back out of memory, people tend to give up too soon. It turns out that there's a lot of stuff that's in your memory, but it needs work to extract it. It needs various sorts of searching strategies. Now, one study asked people who were considerably older to remember their high school classmates. In the first pass, people were just terrible at this. Maybe they had a couple friends that they kept in touch with and they could remember them, but otherwise they were pretty bad. And this is a good experiment because you could use it. You could use, say, for example, a high school yearbook to judge whether or not they were right or not. But then what you do is you tell the person, look, keep trying. Who was your teacher? What sorts of clubs did you belong to? What sorts of sports did you participate in? What were the things that you enjoyed about school? What were your favorite classes? What did you normally eat for lunch? What did you do on your breaks? And pretty soon, as they start to think about all these other experiences, they're able to retrieve a massive amount of information, and they're able to remember almost all of their high school classmates. Retrieval needs a lot of strategies. And we need to learn those strategies, and we need to help our students to learn those strategies as well. And in so doing, we are able to help our students to encode the information better and to retrieve the information better. And all of this helps to unlock that unlimited capacity of long-term memory that is so incredibly essential for success in life. And that's it for this lecture. See you next week.